learners. Welcome to SWAM online lecture series on the topic Database Management System. Myself, Muhammad Ubadullah Bukhari, working as a professor in the Department of Computer Science, Aligarh Muslim University, Aligarh. I am pleased to have you join me today as we explore the fascinating realm of database and database management system. In next few minutes, we will journey through integrity of databases, confidentiality of databases, integrating integrity and confidentiality in the database management system that form the backbone of modern information system, which is a database management system. Before going to discuss in the last week, on the last lecture, I have discussed about the introduction, then access control. Unauthorized persons are not able to access the sensitive data, the encryption techniques. Encryption also, you have to encrypt the sensitive data. Auditing also log. I have also discussed auditing and practical implementation. Before discussing today's agenda, I would like to discuss about the answer of the question which I have given you in the last class. The first question was examine the role of access control in safeguarding sensitive information. Provide example of how different types of access control such as role-based access control and mandatory access control contribute to preventing unauthorized access. Access controls are essential in preventing unauthorized access to sensitive information. Role-based access control ensures that the individuals are granted access based on their roles within an authorization. Within an organization. For instance, in a financial institution, a teller would have access to customer transaction records, while the bank manager would have broader access to financial report. Mandatory access control enforce access policies based on the classifications such as security clearance level in military or government settings. This ensures that the individuals only access information appropriate in their clearance, enhancing overall data security. The next question was discuss the significance of encryption in securing sensitive information. Provide example of where encryption is commonly applied and explain how it helps to protect the data integrity and confidentiality. How it helps protect data integrity and confidentiality. How it helps to protect data integrity and confidentiality. The answer is encryption plays a crucial role in securing sensitive information by converting readable data into unreadable format using algorithm. It is commonly applied in various scenarios such as securing online communication through SSL or TLS encryption in web browser. This ensures this ensures that the data exchange between the users and website remain confidential and cannot be easily intercepted. Files and folder encryptions like using BitLocker and File Vault protect data at rest on devices, preventing unauthorized access encryption not only safeguard data confidentiality but also ensure data integrity by making it challenging for malicious actors to tamper with encrypted information without the proper description keys. The next question: how does auditing contribute to overall security of sensitive information? Provide example of the types of auditing such as system logs and data auditing and explain how they help in identifying security breaches. The answer is auditing is essential for monitoring and recording sensitive relative Auditing is essential for monitoring and recording activities related to sensitive information, contributing significantly to overall security. System logs and event auditing tracks user actions and system events, allowing administrator to review and identify any unusual activities. For instance, monitoring login attempts and tracking changes to system configurations are crucial in early detection of potential security threats. Database auditing, on the other hand, focuses on monitoring changes in database, ensuring the integrity and security of stored information. Regularly reviewing these logs aids in identifying the security breaches and facilities a timely response to mitigate the potential risk. The, the last question was explain the concept of layered approach to data security and how access control, encryptions, and auditing can be integrated to create a comprehensive strategies. Provide example of how these integration enhances the overall protection of sensitive information. The answer is a layered approach to data security involves integrating multiple security measures to create comprehensive and resilient defense against potential threats. Access controls, encryption, and auditing plays vital roles in this strategy. Access controls restrict authorized access control restrict authorized access, ensuring that only authorized individuals can interact with sensitive information. Encryption secure data during transmission and storage, protecting it from interception and tampering. Auditing provides retrospective analysis of system activities, aiding in the identification of security breaches. So the agenda of today is to discuss is first we'll discuss about the integrity of database. Already you are about the what is the integrity. So integrity of database ensure the consistency and accuracy and reliability of data on the stored database. I mean to say that by very simple example, we can say that suppose you are developing a student information system. For that, you have to assume a student ID is the primary key. It means a student ID ensure that when you are entering a records, it must not duplicate, it must be unique, so it will ensure the integrity of that. I will discuss in detail the types of integrity of databases, advantage of integrity of data, what are the advantages of integrity of databases. So we can implement the advantage of database by applying the referential integrity and the rules, integrity rules you have to follow. Then these are the advantages for that. Disadvantage of integrity databases: confidentiality of a database. It must be unauthorized person cannot access the record. It means it will not access the unrecords. That's why we have to confidentiality of database are very important to protect from unwanted personal read, for corruptions, for, you can say, thefts. So unauthorized person cannot update the data for that. So confidentiality is very important for sensitive data. Types of confidentiality databases, and the last we'll discuss about the difference between integrity and confidentiality. So we come one by one. Integrity of database. On the screen you can see that data integrity refers to the accuracy and consistency of data within database. Ensuring integrity is a vital to avoid error, corruptions, and unauthorized modifications that could compromise the reliability of the stored information. To maintain database integrity, several techniques can be employed. It means unauthorized person cannot modify, otherwise the reliability of the stored information will be breaches. Constraints you have to apply. You can apply the primary key, foreign key. You can, and some constraints you can apply on the at the time of a data structure, so that it will ensure the uniqueness and relationship between the data elements. And also you can add the validation rules to compute validations. It means for you can say transaction managements with ACID property. It means atomicity, consistency, isolation, and durability will ensure that database operations are executed reliably. I mean to say that validation rules further contributes by ensuring that only valid data is entered into database. Next is, we take one example of a bank database where constraints are implemented to guarantee that each customer account is assigned a unique identifier, a primary key, you can account number, you can take. The transactions are then implied to deduct the money from one accounts and credit the money to another accounts. And in this way, the consistency in the database will be maintained. So come to the point, the types of data integrity. We discuss about the database. There are different types of database integrity: entity integrity, referential integrity, domain integrity, and user defined integrity. Depending on what you can define your integrity also. So what is the referential integrity? That ensure the relationship between the tables are maintained. Especially it ensures that the foreign key values in one table corresponding to the primary key to the other tables. Entity integrity means this will ensure that each row, or you can say each record, or you can say each tuples in a table has a unique identifier. You achieve by through a use of primary key. By every table, when you are created in a table, that table must have a unique identifier, must have a primary key. Domain integrity means it enforces the valid data types. It means when you are entering a record in a particular column, it must be ensured that the value you are entering, it must be same data types, and must follow the constraint also. It will prevent the insertion of inappropriate or incorrect value. User-defined integrity allows database administrator to define a specific rule or constraint to meet the unique requirements of the database. This can be include business rule. You can add a validation checks. You can add depending on the requirement of the organization. You can add some rules or other custom constraints that go beyond to the standard types of integrity. So depending on that, you can define your integrity. There are 4 types of integrity. You have to know that. Come to the next is then everything advantage. You have to know what are the advantages for data integrity. Data accuracy. Data must be accurate. Redundancy should be maintained, and we have to remove the redundancy. Inconsistency should be maintained, and integrity will be maintained. The next is consistency, data reliability, and the prevention of data redundancy, and the enhanced data security. Data accuracy, integrity constraints helps maintain the accuracy of data by ensuring that value stored in the database adhere to predefined rules. This reduces the likelihood of errors. This reduces the likelihood of error, inaccuracies, and inconsistencies in the database. By that, data must be, data must be accuracy. You have to data accuracy. Integrity constraints help maintain the accuracy of data by ensuring that the value stored in the database adhere to predefined rules. This reduces the likelihood of errors, inaccuracies, or inconsistencies in the data. Consistency. Database integrity ensure the consistency in the relationship between tables. For example, referential integrity guarantees that the foreign key in one table corresponding to a primary key in another table, preventing the orphan or mismatched records. By that, we are able to identify the mismatched records. The next is data reliability. With integrity measures in place, users can rely on the data to be trustworthy and consistent. This is the crucial for decision-making process and other critical applications that depends on the accurate and the reliable informations. Prevention of data accuracy, it means entity integrity, particularly through the use of primary key, helps to prevent the creation of duplicate records in the table. This reduces the redundancy and ensure that each record is uniquely identified. No redundancy are available. No redundant data is available in your database. So these are the advantages. And the last advantage is that advanced data security, integrity measures contribute to overall data security by enforcing this access control, encryptions, the other security mechanism we implement. By that, data can protect sensitive information from unauthorized access, maintaining the confidentiality of the data. So these are the advantages. The next is the disadvantage of that also. Disadvantage is the complexity of the implementation. Naturally, it involves the integrity constraint. You have to apply that there are different types of constraints, especially in the complex database structure, can require careful planning and design. If you are not careful, it means it is very difficult to implement. So implementation is very difficult for that. Performance overheads is also a next disadvantage for integrity of database. Impact on the system performance, it will impact the performance. Some integrity checks you have to apply, such as foreign key, already explained, might impact the aspect of certain operations, particularly when performing a data modifications, a data insertion, deletion, and updation. Also, it will take some performance, will be slow. Potential for false or positive negatives. Overlay strict integrity constraint may sometimes lead to false positive where valid data is rejected, or false negative where invalid data is accepted sometime. So restrict the right balance on be challenging. So these are disadvantage for that. Increase development times. The process of designing and implementing, and then you have to test the integrity constraint, what you have applied for that, it will extend the development time for database application. So it is very time consuming. So these are the advantages for that. So disadvantage. The next topic is confidentiality of database. Database confidentiality involves protecting sensitive information from unauthorized access in an era where data breaches are increasingly common. Safeguarding confidential data is of utmost importance. So confidentiality data is very important. Then you have to apply the access control also. In access control, you have to use role-based access control, play a crucial role in restricting access based on the user's role. Encryption is another key technique applied to protect data both at rest and in transit. So access by encrypting sensitive data, even if unauthorized access occurs, the data remains unintelligible to unauthorized entities. It means you have encrypted data, but unauthorized person are able to access the data. At that time, the data he recovered is unintelligible to understand to unauthorized entity, you can authorized person. So by encrypting, we are able to save our sensitive data. Then there are different techniques, masking and redaction techniques further enhance the confidentiality by selecting, revealing, or cancelling specific data elements based on user permissions. You can apply it. So these are confidentiality. Then same way there are different types of confidentiality of database. Same thing, access controls, encrypted meaning, encrypted, secure communications, role-based access database auditing, the last role-based access control. The first is the access control. Access control mechanisms are implemented to restrict access to the database. Encrypted meaning it is transformed in a format that can only be read by individuals or system with appropriate decrypt key. It means if a person who have the, you can say, public or private key, whatever, depending on, he can read or he can access the data. Secure communication protocols we have to use, such as HTTPS, are used to ensure that data transmitted between the client and database users are encrypted, reducing the risk of interception and if persons are not able to retrieve for that. Role-based access database auditing, it means database auditing involves monitoring and logging activities within the database. It means in future you want to, who is using the system, who have used the system, you are able to modify whatever, you are able to trace a unauthorized person, maybe depending if accident will happen. RBC is a method of access control where access permissions are tied to roles. These are very important, are tied to roles, and users are assigned to specific roles based on their responsibility. So these are the types of confidentiality database. Also, I've told masking and redaction. Sensitive data can be masked or redacted to show only a portion of information to a certain user. Tokenization. Also, tokenization involves replacing sensitive data with a unique identifier that has no meaningful information. Physical security also you can apply it. Physical security means are implemented to protect the hardware infrastructure where the database used. It means for database you have need a hardware also, a special hardware also to store for that. Data classification. Organization classify data based on its sensitivity and importance. This helps in applying appropriate security measures to the most critical information. Regular security audit and assessments. Periodic security audits and assessments are conducted to identify vulnerabilities and ensure that the security measures are up to date. So you have to regular security and audit and assessment. We take one example. Consider a healthcare database you can see on the screen where access controls are implemented to restrict access to patient records based on the user's role, ensuring that only authorized person can access our healthcare data. Suppose such as doctors and the nurses can access sensitive health information encrypted, or you can say encryption is then applied to secure patient data during transmission between different systems, minimizing the risk of unauthorized interception. When you are doing the transmission of data from one system to another system, also you have to make you have to do some encryption techniques you have to apply it for during the transmission. Then the difference between integrity and confidentiality. Then there are some objective why we do this activity. Aims to maintain the correctness and reliability of data, preventing unauthorized or accidental alteration that could compromise its accuracy. Confidentiality aims to prevent unauthorized access to sensitive information, ensuring that only authorized user can view or modify a certain data. The example I have taken for integrity and for confidentiality. Integrity ensuring the data entered into database is accurate, consistent, and follows defined rules. It means data types constraints. This includes preventing data corruptions, unauthorized modification, or errors. Confidentiality, for example, encrypting sensitive data, implementing access control, and using authentication mechanisms to restrict access to confidential information, protecting it from unauthorized users. Method of implementing for integrity implemented through a use of constraints, validation rules, and data integrity checks. This may include primary key constraint, foreign key relationships, and check constraints. By that you can implement for that. For confidentiality, how you will implement? Implement it through access control, encryptions, and user authentication mechanism, access controls list, role-based access control, which I've already explained, and encryption algorithms are common used to enforce the confidentiality. In this way, we are able to implement the integrity and confidentiality into database. Now, let's assess your knowledge and track of your progress with some thought-provoking questions based on the topic which I have discussed. Your answer will not only reinforce the understanding but also serve as a variable gauge of your grasp on the crucial topic which I have discussed today. The first question is explain the importance of data integrity in database and provide an example of how constraints contribute to maintaining a data accuracy. The next question, discuss the role of access control in maintaining the confidentiality of database. Provide an example scenario where role-based action control, where role where role-based access control is essential. The next question is how does encryption techniques contribute to the confidentiality of the data in database? Provide an example of a situation where encryption is crucial. explain the concept of holistic approach to database security. How does integrating integrity and confidentiality measures create a more robust defense against the security threats? In our exploration today, we have navigated the intricate world of data integrity of database and confidentiality. I hope you enjoyed this exploration. Thank you for your thank you for presence in my lectures, and thank you for your presence in my lecture, and and I hope you will be present in my upcoming lectures. Wish you a wonderful day ahead.